Hi guys, today's lesson is over solving proportions using scale factor. In particular, we're going to go over here some figures where you're working from a small figure to a larger figure using scale factor. If some of you are asking the question, well, what is scale factor? Scale factor is just the number used to multiply the lengths of a figure to stretch or shrink it to a similar image. Okay? So we're looking at images here and we're using multiplication to find the lengths here, and we're going to show you how this works. All right, so using scale factor, we're going to look at two figures that are similar here. All right, check out figure A, check out figure B. All right, we see figure A here on the left side here of my rectangle has a length here of 5. On the bottom side here of the rectangle, we see that the value here is 2. All right. Notice here now on the similar figure, on B, it's just stretched out here a little bit. All right, the corresponding side to the 5 in figure A is 20 inches here in figure B. Okay, and here is what we're missing right now. We're missing the bottom here of the larger rectangle. All right, the base, if you want to call it, depending on how you look at it here, how it's shaped. All right, so to use scale factor here, we just want to simply know how are we getting here from one side to another side, and we're looking at corresponding sides. All right, so sides that are in the same relative position depending on how big or how small they are. So what I'm saying is this: think to yourself, and again, we want to think multiply here. How are you getting, if I were to ask you the question, how would you be getting from figure A 5 inches here on the left to figure B 20 inches here on the left? Okay, how would you be getting from figure A to figure B? What would you be doing in terms of multiplying? So what I'm saying is this: 5 times what number gives me 20? Well, you would know here that 5 times 4 is 20. So we say that the scale factor then from figure A to figure B is 4. That's the number that we multiplied to get from figure A to figure B. Now that's going to help us find the missing length here. To get from 2 then to x, because x is what's missing, we don't know what it is. If we took 5 times 4, we're now going to take 2 times 4 to find our missing length. So 2 times 4 is 8. So now x is equal there to 8. That is what the length is of the missing side using scale factor. All right? Maybe you can fill in the blank on the question here that I'm gonna ask you. All right? So this question that you see, when going from a small figure to a big figure, you must, and think about the operation that you're going to fill in for this blank right here. All right? I'll let you pause it and try to figure it out. All right. When going from a small figure to a big figure, you must, and hopefully the word you said was multiply. Okay? You must multiply. When you're going from a small figure to a big figure, you're multiplying. Again, scale factor, you're just looking for the number that you're using to multiply to get to a similar image there. Okay? Let's take a look though. There's another scenario where you're going to have to solve proportions using scale factor, but you might see it going from a big figure to a small figure. Let's take a look at this next example here. Here I have figure A, here I have figure B. All right, and we said think multiplication. So right now, if we want to do the same thing, if we want to think how are we getting from 15 to 5, what are we multiplying by? Well, we're not multiplying by 3. Okay, 15 times 3 is not 5. But we can think, think in terms of fraction forms, or think about the reciprocal of 3, which would be 1/3. I do know that 1/3 of 15 is 5. So my scale factor from A to B here is 1/3. Give you another way to think about this here. Let's say that multiplication just wasn't working for me here. All right, going from the big figure to the small figure. Instead of multiplying, when you go from a big figure to a small figure, maybe think the opposite of multiplication. All right, and the opposite then of multiplication would be then division. So think in terms when you're going from a big figure to a small figure, division out. How am I getting from 15 to 5 using division? Well, I know that 15 divided by 3 is 5. So now I can do the same thing here on the bottom, all right, of my rectangles to find the missing side here. Well, if 15 divided by 3 is 5, then I'm going to take 6 and divide it by 3. And I know 6 divided by 3 gives me an answer there of 2. So what I like to do when I see proportions here, and I'm using scale factor, and I'm going from big to small, I like to use division. So another way to think, when going from a big figure to a small figure, you can use division. And I'm going to add this in here. I forgot to do that. Forgot to add a word. You can use division. All right. So just remember to kind of summarize it when you're going from a small figure to a larger figure, think multiplication. All right. When going from a small figure to a big figure, you must multiply or think multiplication. And when you're going from a big figure to a small figure, you can use division. Think division. That is your lesson there for today on solving proportions using scale factor. Thank you.